Hi guys, this is lesson 225 from Honors Pre-Calc. We are talking about the sine and cosine or sinusoidal graphs. And we're going to start by talking about question 2-94 from the book. And they want us to sketch a graph for each equation. So first of all, we need to make sure that we know the basic graphs of both sine and cosine. I'm going to use this board later for amplitude, okay? Which excuse me, for sine starts at 0, 0. It goes up first, then down at pi, all the way down to -1 and back to 0 at 2 pi. The cosine graph, so I'm going to use the 5-point method a lot. And when I use the 5-point method, I'm talking about 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi for sine. And as you guys helped me out with in class the other day, 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi 1. Okay, those are the 5 points you need to know for sine and cosine, and that needs to come relatively quickly, that you know the shape and what those ordered pairs are. Remember, they come from the unit circle. We're going to be talking about that a little bit next week. So when I'm sketching a graph for y equals cosine x minus 2, I have to keep in mind my regular cosine curve. And again, if I just sketched really quickly, I have to know that that's one period. Here's 2 pi, here's 0, here's pi. I didn't do a real good job of drawing to scale, but it goes up to 1 and it goes down to -1. That's my regular graph. Now this -2 at the end, remember, tells me that I'm going down 2 units. So everything shifts down 2 units. The highest point in my graph shifts down. The new highest point is now going to be here at -1. My lowest point shifts down 2 units. It's now going to be at -3. And I talked about this a little bit in class, but this -2 is my midline, or it's kind of like my new x-axis. So I'm going to take every single one of these points and basically pretend like this is my x-axis. I am starting here at pi. I'm going to be down at -3. I'm going to be coming back up to -1 at 2 pi. In the middle, so pi over 2, I'll be at -2. And in the middle here, at 3 pi over 2, I'll also be at -2. And here's where you really want to practice. It's not a quarter of a circle, but it kind of looks like that. And when you're sketching it, it's kind of quarter of a circle this way, quarter of a circle that way. It is not the same shape as a quarter of a circle. But when I'm sketching it, that kind of helps me get the shape right. Otherwise, it looks really like an absolute value. This isn't perfect, but it is an accurate sketch. Okay, this next one, part C, and I intentionally skipped part B. I want you to practice the other ones, or have an opportunity to practice the other ones. So this one, instead of cosine, they want you to use sine, and instead of moving up or down, they're actually moving us to the right. So remember, anything that's trapped in parentheses with an x is going to do opposite of what you think. Okay, so this is actually moving to the right, pi over 4. So again, here's just a sketch of the quote-unquote normal sine curve. Here's pi, here's 2 pi. It goes up to 1, it goes down to -1. Now this time we're not going up or down at all, so we're going to keep the same midline as normal. And again, this time we're just scooting to the right, pi over 4. Okay, we know that this, let's do this, is pi over 2. We know this is 3 pi over 2. So if I add to these 1, 2, 3, 4, 5 values, if I add a quarter pi, I'm just shifting everything to the right 1/4. Okay, of course 1/4 is half of a half. Okay, so that helps me go right in between. This is going to be 1/2 plus a fourth, so 3/4. This is going to be 4/4 plus a fourth, or 5/4. This is 6/4 plus a fourth, 7/4. And this is 8/4 plus a fourth, 9/4. Okay, and then I'm just going to start here. Again, I'm going to go up first, then back to the center, midline. then down all the way to -1, and then back up to 0. And again, this is just one cycle of the graph, and we could continue the pattern either direction, right or left, but that's a sketch of the graph. One more I want to look at for number 94, and that's combining a horizontal and a vertical shift. Okay, so remember, in parentheses with the x, we do opposite, so this is actually left pi over 2, and this one is up 1. Anything outside the parentheses is vertical. So I'm going to start with the plain or regular cosine. Did I do this bottom one right? Yeah, I did. Okay. And again, my normal starts at 1. My lowest point is -1. Okay, it's cosine. Here's pi. Here's 2 pi. I try and make those even, and then I go in the middle, pi over 2, 3 pi over 2. That's going to be my normal. Go down. Keep going down, come back up, go back up to the top. Again, it's a sketch, it's not perfect. We're getting the idea, okay? And we're gonna go left pi over 2 and up 1. So if I'm going up 1 from 1, my highest spot is 2. If I'm gonna go up 1 from -1, my lowest spot is here right at 0, and my midline is exactly in between those. Okay, it's here at y equals 1. Okay, I also have to shift to the left, pi over 2. So I'm going to take, instead of 0, I'm going to put a spot at -pi over 2. And then I'm actually going to use 0, pi over 2, pi, and 3 pi over 4. I'm just going to shift everything over. So when I do that, this is my highest spot. Oops, nope, that's my midline. Sorry, this is my highest spot. I'm pretending this is my new x-axis. This is my highest spot. I'm going here, 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 highest spot again. Okay, so I have sketched each of the graphs that we have. Okay, next question is question number 95, and we're going to start talking about amplitude. Okay. So amplitude is the height, kind of. Okay. Amplitude happens from the midline up to the peak. That's 1 unit, from 0 to 1 unit. Or you can think of it from the midline down to the lowest valley, which is also 1 unit. Some people like to find the lowest and the highest and say, okay, that's 2, and divide by 2. That's fine, but what you need to realize is that the amplitude is just from the middle to the highest point. It's not the whole thing, okay? So same thing when we're talking about cosine. When we go from the midline to the highest, it's still 1. You could go midline to lowest, 1, for a regular sine or cosine graph. In number 95, they also want me to sketch a transformation that has an amplitude of 3. Okay, so what they want me to do is sketch. Oops, I should have done that in red. Not a big deal, but I started on this graph in red. So y equals, the amplitude always goes in front. It is a vertical stretch. So if I want my amplitude to be 3, it just means I have to change. This is not going to be very much to scale, but I'm going to do my best. So 1, 2, 3. So 3 is clear up here. 1, 2, 3. I didn't plan that out very well, did I? -3. Okay, so we're just stretching everything vertically. So 0, 0, if you stretch from the x-axis vertically and you're at 0, you're not doing anything. So any point that's at 0 actually doesn't move at all. Okay, but if you're at 1 and we're stretching vertically, we're going all the way up to 3. If you're at -1, we're going all the way down to -3. Okay, so this point's going to stretch all the way up to 3. This point's going to stretch all the way down to -3. And of course, I'm going to run into my other notes. But again, 0 stayed the same. It just becomes more stretched out. Okay, and of course, that's supposed to go through that point. Okay, and we wrote the equation that goes with it. Then this last part, part C of 95, says sketch a transformation of y equals the cosine of x that has the amplitude of 1/2. Okay, so this time they want us to graph y equals 1/2 cosine of x, and I'm going to be doing the same thing. I'm going to do a horizontal compression though, because I'm only going to go halfway up. So anything at 0 stays at 0. That does not change. Okay, but anything at 1 only goes up to 1/2. Anything at -1 only goes down to 1/2. So it's half as tall. Maybe the mountains are half as tall, the valleys are half as low, I guess. We're still trying to get that nice curve in. It's a sketch. Okay, but you can visually see what happens when the amplitude is less than 1, or when the amplitude is greater than 1. Less than 1 but bigger than 0. Okay? The last concept that we need to talk about is period. Okay, and this is a big concept, and this is probably the one that gets most easily confused, maybe I would say, or people aren't sure about how to do this. So again, what I have to start with, these are all sine graphs. Of course, we talked in class, any of these graphs you could write as sine or cosine, just as a shift. But let's think of them as the sine graph. Okay? Period is, let me see if I have a really good definition here I can just read to you. Yeah, the period is the horizontal length of one complete cycle of the graph. The horizontal length. So amplitude is the vertical distance, kind of, half the vertical distance. Okay? The period is the horizontal length. So how long does it take along the x-axis to do one full cycle? Okay, and remember in the sine curve, you start at 0, 0, you go up and down, but then you go all the way down and back up. That is one full cycle. So in the regular non-transformed sine and cosine graphs, the period is 2 pi. And that's what we've done the most of. So this graph here is actually showing 2 periods of the graph. It's 2 cycles. Up and down and back, up and down and back. 2 cycles. So one cycle is 2 pi. Okay? Now let's see what's happening here. This is up and down and back in just pi. So in this case, the period is pi. Okay? This one at the bottom, it's up and down and back. Ooh, what is that? Here's another way to tell. So that's 1 period, up and down and back, 2 periods, up and down and back, 3 periods in 2 pi. 3 periods in 2 pi. So what's the period? The period is 2 pi over 3. This is one of my favorite equations in math. Okay, and we'll get to this and we'll talk about this in a second, but PB equals 2 pi. That's a really, really, really good thing for you to remember. Peanut butter pie, peanut butter equals 2 pi. I don't know. I don't even like peanut butter pie, but that's an easy one for me to always remember. Okay, period times the B value is equal to 2 pi. So if I want to write an equation for this graph, we've already have the equation for the first one, but if I want to write an equation for this graph, okay, I haven't translated this graph at all. I've only done a horizontal shrink, really. And if I want to know what the B value is, so I'm going to say, well, I know y is equal to sine of some B value times x. If I know the period is pi, I can say PB equals 2 pi. Okay, period is pi, so pi times B equals 2 pi. Divide by pi. Giant 1, B equals 2. So my equation here is y equals the sine of 2 pi. So remember, we talked about if it's trapped in the x, if a number's trapped in the x, it actually does opposite of what you think. Usually we hear 2 and we think it's going to stretch out, but because it's in with the x's, the 2 actually is a horizontal compression of 1/2. Okay, now let's see what happens here. Again, we want to write an equation, y equals the sine of something x. Okay, we should be able to identify, hey, this is the sine curve, and what we've done is we've done a horizontal compression. Okay, and so we already identified that the period is 2 pi over 3 by counting. There are 3 full periods in 2 pi. 2 pi is equal to 3 full periods, so I just did, oh, that's easy, divide by 3, 2 pi over 3. Okay, and we've already kind of talked about this. So peanut butter equals 2 pi. We said the period is 2 pi over 3 times b equals 2 pi. Okay, well, let's just get rid of the fraction by multiplying by 3. 2 pi times b equals 6 pi, right? 3 times 2 pi is 6 pi. Divide both sides by 2 pi. Giant 1 here, 6 divided by 2 is 3. That's what we started with here. So our equation for this one, it took 3 periods in 2 pi. That is also the value of b. So there's 2 ways to find b. One is if you can easily tell what the period is, using peanut butter equals 2 pi is a good way to solve. Or how many times is there a full cycle in 2 pi units? How many times here is there a full cycle? 1, 2. 2 is my b value. Okay, so let's look at this third one. How many cycles happen between 0 and 2 pi? Well, that's only half of a cycle. So this case, this is sine of 1/2 x. Okay, or I can say, all right, my period, it takes 4 pi to get to 1 period. The period is 4 pi. So what's my b value? Peanut butter equals 2 pi. Period is 4 pi times b equals 2 pi. Divide both sides by 4 pi. Okay, 4 and pi, giant 1, pi and pi, giant 1, 2 over 4, 1/2. Okay, also in your notes, again, we've just talked about this, peanut butter 2 pi. Remember that this is our general form of the equation for sine. It works exactly the same if I were to put cosine here. It just is a different first 5 points. Remember, the A stands for amplitude. Okay, the B is actually called angular frequency. Let me make sure I'm getting that spelling right. Yep, angular frequency. And again, oops, not CE. It's not Beyonce. Okay, angular frequency is how many times does a full cycle happen between 0 and 2 pi. That's the definition of angular frequency. Okay, again, keep in mind peanut butter equals 2 pi. That's going to be an easy way to help you figure out going between the angular frequency and the period and vice versa. B is not the period. Okay, B is not the period. Period times angular frequency gives you 2 pi. Or some people like to think of it as the period is 2 pi divided by angular frequency. It's all the same. Okay, it all gets you to the same spot. Remember, H is